Hi all, in this video we're going to see about iron absorption. So how is the iron that is ingested or the iron that is formed by the breakdown of hemoglobin absorbed into the bloodstream? So we'll see how it is done. So iron is mostly absorbed in the upper part of small intestine, that is mainly in the duodenum and jejunum. So for example, if this is the enterocyte and this is the apical and the basolateral part of the enterocyte. So first step is that we have to convert that iron, which is usually in the ferric state, to the ferrous state. So to do that, we've got a protein which has a ferric reductase activity, and that is called DCYTB or duodenal cytochrome B. So this will help to convert the ferric to ferrous. And once the ferrous is formed, it is taken into the enterocyte by the help of this apical membrane ion transporter. It is called DMT1. It stands for divalent metal transporter 1. Divalent metal transporter 1. Now this occurs along with the transport of H+. So thus now the ferrous is inside the enterocyte. Now we know that this here till now we've just told what happens to the dietary or ingested iron. What about iron that is released from heme? So heme also enters the enterocyte, and from heme the heme enters by a transporter called HCP1. It stands for heme carrier protein. Heme carrier protein. So heme carrier protein will transport heme into the enterocyte. And from this heme, iron is released by means of an enzyme which is called heme oxygenase 2. So heme is acted upon by heme oxygenase 2, and that also releases the iron. Now thus we've got a lot of iron in our enterocyte. Then what happens? Some of the iron is converted to ferric form and is stored as ferritin, whereas others, some of them, is transported out of the enterocyte by means of a channel called ferroportin 1, FPN1. Ferroportin 1, which transports the ferrous present inside the enterocyte out into the bloodstream. Now before it can be transported to the bloodstream, it has to be converted back to ferric. So for that we've got another protein which is called hephaestin. So this hephaestin will convert ferrous to ferric, and now this ferric can be combined with, or it along with transferrin is transported into the blood. Okay, so this is how the digested iron as well as the iron that is released from heme is transported inside the blood. Okay, so I'll just repeat the steps once again. The first step is conversion of ferrous to ferric by means of a ferric reductase, which is called duodenal cytochrome B, and then the ferrous is taken into the enterocyte by the help of a divalent metal transporter 1. Now the ferrous is inside the enterocyte. Not only from the ingested iron, we've got heme also transported into the enterocyte by means of a protein called heme carrier protein 1, which when acted upon by an enzyme called heme oxygenase 2 releases the iron from the heme. So now iron is present inside the enterocyte in the ferrous form, of which some of it is stored as ferritin in the form of ferric ion, while others are transported into the outside the enterocyte by means of a protein called ferroportin 1. And once the ferrous ion is outside the enterocyte, it has to be converted back to ferric, which is done by hephaestin, and then it is transported inside the plasma bound to transferrin. So thus we now know how iron is absorbed into the bloodstream. Not only the ingested iron, but also the iron that is released from heme. So I hope this was useful for you. Thank you.